A normal combustion is that we have seen that combustion SI engine can be classified into two categories. One is normal combustion, another is abnormal combustion. We have discussed that in case of a normal combustion, flame which is being initiated because of the spark plug, that will travel across this combustion chamber in a fairly uniform manner, whereas we will discuss now that in case of an abnormal combustion, again it can be subclassified into two categories: pre-ignition, rather the abnormal combustion has two different parts, one is pre-ignition, another is detonation knocking, where flame, which is the existence of visible flame, is essentially an indication of combustion. So in case of abnormal combustion, that flame which is being developed because of the spark plug, switching on the spark plug, that flame won't be able to travel in a fairly uniform manner, rather that flame will be disturbed by the other flames in the combustion chamber. So we need to know, maybe we are telling that the main flame front will be disturbed by the presence of other flames in the combustion chamber. So we need to know what are the sources, rather origin of the other flames in the combustion chamber, and or other flames are obviously there because of which the main flame will get disturbed, rather the travel of the main flame front will be disturbed. So knowing that, okay, fine, there are other sources from which the secondary flames are being developed, then we need to know how can we prevent the formation of secondary flame, and even we cannot stop completely the formation of secondary flames in the combustion chamber, how we can mitigate the travel of the secondary flames, so that there should not be any problems which will essentially give rise to abnormal combustion in the combustion chamber. So before I go to discuss about this, let us briefly recapitulate what we have learned from the beginning of this course, that what are the different strokes in a SI engine. So if we can recall that in case of a spark ignition engine, we have 4 different strokes. Of course, if it is a 4-stroke engine, whether it is 4-stroke or 2-stroke, in case of a 4-stroke engine we have intake, compression, power and the exhaust. In case of a 2-stroke engine, we have power stroke, and intake, compression and ignition, intake, compression and exhaust strokes are occurring in a same stroke. So during the compression stroke, if I try to write, that is very important that we have discussed how that in a compression stroke we are rising the pressure of the charge which is being introduced during intake stroke to a limit, so that at the end of the compression stroke, in case of SI engine, we need to switch on the spark plug to ignite the entire charge, or in case of a CI engine, we have seen that we need not to use, we do not have any spark plug or external agent like spark plug, but still we are utilizing the high pressure and temperature of the compressed substance itself to ignite the fuel, because we need to supply fuel through fuel injector or fuel pump in a finer spray pattern. So the moment when which fuel is being injected into the combustion chamber during the end of the compression stroke, the pressure and temperature of the compressed air will itself allow the fuel to be ignite. So if I try to now write the it is very important that crank angle and pressure diagram. So if I try to write that, if I try to draw, this is theta, this is crank angle, and this is of course pressure rise P. So this is pressure rise. So maybe we need to know. So this is the location of the TDC, and maybe this is BDC, bottom dead center, and this is also bottom dead center. So this is compression stroke, this is compression, and it will last up to this point. Then this is again expansion stroke, and it will last up to this point. So this compression and expansion, so piston is coming from BDC to TDC compression stroke, and again it is coming from TDC to BDC during power stroke, and during that stroke what is happening in terms of pressurized inside the cylinder, that is what is now our objective. So just if we have a curve, this is the monitor curve. So if we do not have any combustion, rather we have a compression stroke, then so this is known as monitoring curve. So, if we just move the piston using an electric motor, we will get curve like this. So, we have air inside the cylinder, we have taken air during intake stroke, and then we have closed valves, that is intake, both the valves, intake and exhaust, and just I am moving piston using an electric motor. So, then it will, during the compression stroke, pressure will increase, that is reflected in this diagram, and again during expansion stroke, pressure of the air will decrease. So, what is done at the end of the compression stroke, maybe we are switch on the spark plug when if I try to recall when piston is close to that point. So, here we are having a spark location. So, this is point A. So, point A is the spark plug switch on. So, if I switch on the spark plug at the end of the compression stroke when piston is very close to TDC, then the spark plug will switch on, will try to initiate, allow the combustion to be initiated, and there will be a rise in pressure, peak pressure, then it will follow the same curve. So, peak pressure is happening over here, let us say point 1. So, 1 is the peak pressure rise when sparking is done at point A. So, when we switch on the spark plug at point A, then there is a rise in peak pressure at point 1. Because of the combustion, the pressure will be high, temperature will be also high. This diagram is very important, and we will keep this diagram as it is, and we will now again superimpose another curve after some time. So, now we will discuss about that. We have seen that normal combustion is fine because there is no erratic movement of the flame, and flame moves almost in a fairly accurate manner, in a fairly uniform manner in the combustion chamber. But now I will discuss about the abnormal combustion. So, abnormal combustion, I am writing abnormal combustion, that is having another two different parts. One is pre-ignition, sometimes it is known as surface ignition, and another is detonation or knocking. So, these two are very important. I can tell you that whenever we start internal combustion engine, particularly spark ignition engine, then if I draw the schematic again, maybe so this is the piston, and we have spark plug over here. So, if I draw the if I take a top view of this cylinder, and then maybe here we are having spark plug. So, now when you switch on the spark plug, there will be a initiation of combustion, and as I said that the indication of combustion being initiated is the appearance of a visible flame. So, indication of initiation of combustion is the appearance of a visible flame inside the combustion chamber. So, maybe this is the location of the spark plug. So, when combustion is initiated, a visible flame that will appear, and not only that, this flame will try to expand, and it will try to expand inside the combustion chamber, and the charge which is very close to that flame again will take part in the combustion, and in this way the entire charge will be will take part in the combustion. So, during the first whenever we start the engine, then there is no problem, but after a few cycle, then because of the continuous combustion, then the cylinder face, cylinder wall as well as surface of the piston will be having higher temperature. So, when we start our engine there will be no problem, but because of this continuous combustion there will be a time maybe at the later part of the cycle, that is engine is running continuously. So, piston face, so if I draw the piston, then piston face also will be having higher temperature. So, this is piston. So, this piston face also will be having higher temperature. The temperature of the piston face as well as the cylinder wall will be higher because of the continuous combustion, because these walls, solid walls, are sustaining the combustion temperature. Now, what will happen? A time will come, this is the actual spark plug, there will be location inside the combustion chamber which will be acting. There will be different locations within the combustion chamber, those locations will be acting as a artificial spark plug. So, that means there will be a situation, because when we have compressed the air, maybe always we are this 4 strokes are continuous. So, maybe after certain cycles, whenever we are taking fresh air, we are fresh air fuel mixture, whenever we are compressing, because of this hot spot, that means those which are acting like an artificial spark plug, that means face of the piston as well as the cylinder walls, the temperature will be so high that the charge which are in contact with those locations will be able to there the combustion may take part, combustion will initiate. So, that means this hot spot like piston face and cylinder walls are the location of the exhaust manifold also, there where temperature is excessively high, those locations will be acting like an artificial spark plug, and whenever a fresh charge during compression stroke is coming in contact with those hot spot, then those hot spot will allow the charge which are in contact with those spots to initiate combustion. So, that means there might be a situation when maybe the charge at the remote locations from here. So, here we may have another flame front, here we may have another flame front, here we may have another flame front. So, these flame fronts again will try to proceed in the from that location to the surrounding places. So, main flame front is coming because of the spark plug, but because of the continuous rise in or excessive rise in temperature because of the continuous process, there will be hot spot from where this hot spot temperature is so high that the temperature will allow the fresh charge, the compressed charge to be ignited from those locations, as a result of which the main flame front is proceeding towards the further downstream. Not only that, the another flame front also will try to proceed further, and as a result of which there will be excessive rise in the pressure. So, excessive rise in pressure and temperature again will try to increase the temperature, and this excessive rise in pressure and temperature will not only will it is a continuous process, this is cumulative effect. That means this flame is coming, so again it will keep on increasing temperature and pressure. So, this rise in the pressure and temperature, this cumulative effect not only will tend to raise the temperature and pressure and which may create another problem about problem detonation knocking, but also it may create the peak pressure to be occur even further before that. I will now draw in the schematic, and that will even try to reduce the efficiency of the engine. So, now before I go to discuss that aspect, let us see that when main flame front is coming from the actual spark plug location, and because of the secondary flames being developed because of this artificial spark plug, then now this flame, the secondary flames, maybe this is BD, this is AA, this is BB, this is CC, and this is DD. So, the main flame front is coming from location A and another flame front which is going from location BB. There might be a situation when that main flame front, before main flame front, the main flame reaches at the remote at those locations BB or CC or DD, the secondary flames are coming forward, and there might be a situation when these two flames or the flames are colliding each other. So, this collision of the flames will not only will create high pressure and temperature, but this collision will create a violent vibration with resultant noise, which is known as detonation or knocking. So, that means we understood what we understood, that now we need to know how we can control, how we can suppress the speed of the secondary flames being developed, or we cannot completely stop it, but we can mitigate it. What we can do, we can take some preventive measures by which we can mitigate or we can suppress the movement of the secondary flames that is being developed. So, for the timing you should know, the main flame front is coming because of the spark plug, original spark plug, but because of the continuous rise in temperature, there will be locations where temperature will be so high, and those places will be acting like an artificial spark plug. So, whenever a compressed charge is coming in contact with those places, then the compressed charge will be ignited because of the high temperature, and because of this ignition, combustion will also start from those locations and secondary flame will be developed. Now, secondary flame will after the development of the secondary flame, the flames will propagate, that is, the flames will travel. Then if we cannot create a situation that whenever main flame, the time required to proceed main flame front up to the remote location, let us say BB, another flame front, the secondary flame BB is coming further, and these two flames will collide each other and eventually result that a violent vibration, and that will result a noise which is known as detonation or knocking. That means we now need to know that this is the collision of the flames, maybe main flame as well as the secondary flames. So, we should know that somehow we cannot stop, because we cannot reduce the rise in temperature in the combustion chamber. If we reduce, then efficiency will further drop. So, that we cannot do beyond a particular point. But what we can do, we can take some preventive measures, so that although the secondary flames are generated, but we somehow can suppress their movement, so that by the time when main flame will be reaching there, that secondary flame won't be able to propagate. So, and in this way we can stop detonation knocking, that we will discuss. So, what is surface ignition, pre-ignition? That means we told that what is pre-ignition. It's very important that some of the boundaries of the combustion chamber, such as spark plug location, exhaust manifold, top of the piston face and walls of the cylinder becomes overheated under certain operating condition, and because they are because these places are always surfacing high pressure and high temperature. So, their temperature will gradually increase, that is quite obvious. So, and these surfaces are acting like an artificial spark plug. So, and whenever as if artificial spark plug, and whenever a compressed charge is coming in contact with those surfaces, then those compressed charge will be ignited, and as if we are igniting before the main flame reaching over there. So, we are pre-igniting the combustion product. So, that is why it is known as pre-ignition. So, the process is known as pre-ignition. Why it is pre-ignition? Because the furthest charge which are located, the furthest compressed charge which are located maybe in CC, DD or BB, from there even we can see that the charge is getting initiated because of the high temperature. Not only that, secondary flames are being developed. That means even without reaching the main flame front over there, actually we are expecting that whenever main flame is developed from the spark plug region, that flame will try to propagate across the combustion chamber. So, the charge very adjacent to that flame will again, the temperature of the charge which adjacent to the main flame will be higher, and their charge will be ignited, and in this way the entire combustion product, entire compressed charge will take part in the combustion. But what we can see that it is not the case. Even before that main flame reaching the locations like BB, CC and DD, there might be a situation from there we can get flames, that means their compressed charges are getting ignited. So, there are locations in the combustion chamber where we get ignition a priori, that is a pre-ignition. So, this is why it is known as, the process is known as pre-ignition. So, what you can see, this pre-ignition also increases the temperature and pressure. So, pre-ignition tends to raise the temperature and pressure in the process, that is what we can see, because we will have several flames. So, it will increase the temperature and pressure, and because of this higher temperature and pressure, the temperature in these locations and also in the surrounding cylinder will increase again further, in the succeeding cylinder will be increased further. Now, this cumulative effect. So, temperature at that location BB was automatically higher, was already higher. Now, because of this artificial combustion over there, because of the artificial existence of spark plug, I mean because of the hot spot, the temperature will even will be higher in the succeeding stroke. So, the cumulative effect of these not only will tend to raise the pressure and encouraging the detonation to occur, but also it allow the peak pressure, that is the point 1, to go even beyond the closer to TDC. That means there might be a situation when this peak pressure might go even closer to TDC, and so maybe 2. So, now because of this cumulative effect, pre-ignition or surface ignition, peak pressure, the surface ignition will keep on increasing the temperature of those hot spot. Not only that, and in this hot spot or in the succeeding cylinder, not only that, so the rise in pressure and temperature, this cumulative effect not only increase the probability of having detonation and also the temperature, it also will try to it also will try to create peak pressure inside the cylinder during the compressions, during the combustion, which is very closer to the TDC at point 2, what we can see. Now, if the peak pressure even occurs before the TDC, so piston has not reached at TDC, that means before reaching piston as TDC, peak pressure occurs, that pressure will create resistance for the upward travel of the piston, and we will need to sacrifice the overall efficiency of the engine. So, this pre-ignition may also cause damage through burning of this engine. So, what we can see, because of this surface ignition, temperature at certain locations, that is what we have discussed, spark plug, exhaust manifold, piston face will go high, that may leads to damage of that locations, damage of those parts through burning, of course. Not only that, this peak pressure rise will again, the rise in peak pressure will try to, it will enhance of undesirable phenomenon like detonation and knocking. Not only that, the cumulative effect will allow the peak pressure to occur even very close to TDC, and piston, sometimes it may occur even when piston has not reached at TDC. So, during that case, piston will face resistance and we need to sacrifice the efficiency. Not only that, it will make a very jerky operation of the piston. So, as if piston has not moved at TDC, but their peak pressure is rising, so piston will face resistance. So, we will have a jerky movement, jerky motion of the piston. So, this is a very undesirable phenomenon, and this is one part of the abnormal combustion. So, I will write now that what are the consequence of having this abnormal phenomenon we have discussed. So, we can write this abnormal combustion reveals itself in many ways. In many ways, right. So, the major phenomenon are knock and surface ignition or pre-ignition. That is what we have discussed. That is what we have discussed. So, the major phenomenon are knock and surface ignition. So, the abnormal combustion phenomena are of concern because, so the abnormal phenomena combustion phenomena are concerned because Number 1, very important, when severe they can cause major engine damage through burning. That is what we have discussed, that cumulative rise in temperature in those places may leads to permanent damage through burning. So, when severe they can cause major engine damage through burning. Number 2, even if not severe, they are regarded as an objectional source of noise by the engine or vehicle operator. Through the event detonation or knock. So, even if not severe, they are regarded as an objectional source of noise by the engine or vehicle operators through the event of detonation or knocking. So, these are the very important consequences. So, abnormal combustion is not desirable at all. If severe, that is what we have discussed, the rise in temperature and pressure will be so high that it may leads to damage of permanent damage of the engine parts through burning, of course. Even if they are not severe, they are regarded as an objectional source of noise by the engine or vehicle operator through the event of detonation or knocking. So, now we have discussed that what is pre-ignition in detail, we have discussed what is knock, of course, and pre-ignition occur only because of the continual rise of the temperature of some parts of the or some of the boundaries of the combustion chamber, like piston face, wall and exhaust manifold, and these spots can be considered as if the artificial spark plug. So, whenever compressed charge is coming in contact with those locations, we may have combustion from there also, and of course, combustion means we can get we can get the visible flame. So, whenever flame is being developed, that these flames will try to propagate, and there might be a situation when the main flame front will not be able to reach before the secondary flame front start propagating. They will collide each other, and eventually there will be a violent vibration, and we may get a noise, and which is known as detonation or knocking. So, now we should know that by how we can control the detonation or knocking. That means, detonation or knocking, we are having detonation or knocking. This is very important, that if I try to draw again a schematic. So, maybe we are having one spark plug over here. So, main flame front is moving in this direction. Now, if this hatched portion may be acting like a, so this hatched portion is acting like artificial spark plug. So, whenever combustion compressed charge will come, another secondary flame will develop. So, maybe this is A and this is BB, and this secondary flame will try to move in this direction. So, if I somehow can mitigate, suppress the propagation of the secondary flame, there is no chance of having cavitation, there is no chance of having detonation. But if we cannot suppress or prevent the propagation of the secondary flame, maybe that depends upon so many factors we will discuss now. So, there will be a moment when these two flames A and BB will collide each other and will result a violent vibration with an audible noise, and that is known as detonation. So, now there are, so how we can control? First, let me now discuss that if we can control the detonation. If you would like to control the detonation, what we have to do? We have to control the movement of the secondary flame. If we can, by how? There are ways, many ways. If we can increase the speed of the main flame, if we can suppress the speed of the secondary flame, that is possible. Now, if we increase the speed of the main flame, or if we suppress the speed of the secondary flame, there is no chance of having detonation. But if we can increase although the secondary flame is being developed and it will try to propagate. Now, if we somehow increase the speed of the main flame, then what will happen? The time the main flame will take to reach at section BB, by that time secondary flame has not been developed at all, or although it is developed, it has not started its journey. So, by that time the secondary main flame will try to restrict the propagation of the secondary flame itself. So, we can prevent detonation. The hatched portion is acting like a artificial flag. Not only that, sometimes maybe the temperature of that hatched portion is not high to initiate combustion, but whenever main flame front is progressing and this main flame will acting like a piston. So, the movement of the main flame will be as if a piston is now putting pressure on the furthest charge which is there in section BB. So, I am assuming now the temperature of the section BB we can somehow able to control beyond a particular limit. Now, the temperature is not high enough to initiate combustion over there, but the main flame front movement, the movement of the main flame is just like a piston is moving, and a piston is putting pressure on the furthest charge that is there in section BB. So, because of this pressure, the pressure will increase over there at section on the pressure will increase in section BB. So, because of this raise in pressure, again whatever may be the temperature is not so less, but temperature is not enough itself to initiate combustion, but rise in pressure because of this movement or because of the travel of the main flame, the pressure of the compressor of the compressed charge in section BB will be increased, and that pressure will allow the compressed charge to take part in to initiate combustion with that temperature by what is there in section BB. So, what I can say that there are so many ways, there are many ways to control detonation. What are the ways? So, number one is flame's front speed decreases if the flame front so I can see now if the main flame front speed decreases, detonation will be there, this is obvious. So, increase main flame front. So, main flame front speed increases. If main flame front speed increases, then time required for the movement of the main flame will be, if main flame front speed increases, then time required for the movement of the main flame front is not sufficient to go to the critical phase, of the critical phase of the compressed charge in you know in a furthest location so location, and then there will be no detonation. That means what is the critical phase? So, whenever it is very important, what is the critical phase of the compressed charge? Now, as I said you that the main flame front is acting like a piston. So, it is putting continuous pressure on the compressed charge that is there in section BB. So, you know, if I now plot that pressure at section BB will increase, temperature somehow if we can able to maintain temperature of the section BB to a limit which is not sufficient to initiate combustion of the compressed charge that is there now, but because of the movement of the main flame, the pressure of the furthest charge will increase, and pressure is increasing, let us say from 1 to 1 prime, and this is critical pressure. So, this is critical pressure, peak critical or critical phase. Then the compressed charge will require certain amount of time, and if I plot with time versus pressure, then this is known as, this time is known as preparation phase. So, preparation phase, just like a this is known as preparation phase, and then the high pressure rise will be high. So, dPdT will be high. So, this preparation phase which is similar to the nuclear reaction. So, maybe compressed charge that is there in section BB, if the travel of the main flame, the travel of the main flame will try to increase the pressure of the furthest charge that is there in section BB. So, there will be a moment when the pressure of the compressed charge in section BB will be critical pressure. Now, we require certain amount of time, finite time, that is known as preparation phase, that is essentially the which is similar to nuclear reaction, the chain reaction. But if I allow that certain time period, then there will be huge pressure rise because of the combustion. So, then after this preparation phase only the entire combustion from the furthest charge, that is combustion in section BB, will start. So, now if I somehow can increase the speed of the main flame in such a way that the time required up to the preparation phase, the time required to travel the main flame up to the location BB is very less, and even it is lesser than the time required up to the preparation phase of the furthest charge, then there is no possibility of having detonation. So, this is true. By how we can increase, and to increase the main flame front speed, what we have to increase? We have to increase we need to know a full throttle. So, we require full throttle, not partial throttle. So, not partial throttling. So, this is full throttling. Number 2 is, or number 1 is full, A is full throttle, B is if we increase fuel air ratio. So, fuel air ratio is slightly richer. So, if fuel air ratio is slightly richer, then also main flame front speed will increase. So, these are the two. Number 3 is, that is very obvious, that if we reduce the temperature of the furthest charge. So, if we reduce the temperature of the furthest charge, then possibility of detonation will be reduced. So, this is quite obvious. So, if we supply more coolant, so we need to know that if we keep on increasing coolant, then it will reduce the temperature in such a way that again it will drop the efficiency. But if we can maintain the temperature up to a limit which will not allow the secondary flame, development of the secondary flame, then perhaps we can reduce the possible detonation, possibility of detonation. And number 3 is very important, that chemical aspect. Chemical aspect, that is, as I said you, that preparation phase. So, preparation phase, which is similar to this preparation phase, is similar to nuclear reaction. So, it's similar to nuclear reaction. Similar to nuclear reaction, start from a single nucleus, that is, start from a single nucleus, and number of nuclei and number of nuclei participating the chain reaction, participating in the reaction, participating the reaction increases successively, and after certain time this reaction rate is very high. So, this preparation phase similar to that. Temperature of the section BB is not so high, but somehow the movement of the piston is acting like a piston, and it is increasing the pressure of the furthest charge. So, now we require certain time, that is preparation phase, although pressure has reached at the critical value, but we require certain time which is known as preparation phase, just like a chain reaction. So, initially there will be one nuclei, and slowly the number of nuclei participating in the reaction will be increasing, and after certain time the entire there will be huge rate, the rate of reaction will be high, and the entire combustion will be completed, and then the combustion will start. So, the chemical aspect of the fuel is that preparation phase should be larger by controlling the chemical properties of the fuel. So, if we can control the preparation time, preparation phase should be larger, preparation phase should be larger by controlling the chemical properties of the fuel. By controlling the chemical properties of fuel, that is by using additives or using additives, that is by using additives. That means somehow if we can increase the preparation phase by altering the chemical composition of the fuel by using additives, we can see that by that time main flame will be reaching at section BB. So, we can suppress the formation of the secondary flame, formation of the secondary flame in section BB. So, there is no chances of having detonation. So, these are the ways by how we can control the detonation. Also, there might be a situation that if we have by altering the spark plug location. So, if we can somehow engine cylinder is a cylindrical shape. So, instead of putting spark plug in a particular location very close to the boundary, if we can place at the middle, and then perhaps the formation of the travel of the main flame will try to proceed in a fairly uniform manner in the combustion chamber. So, the chances of detonation might be reduced. So, what we can see from this, this is the overall aspect of the SI engine combustion. So, we have seen that somehow we cannot prevent formation of secondary flame, because the temperature and pressure, temperature of some boundaries in the combustion chamber will go high because of the cumulative effect. But although the compressed charge when you are coming in contact with those locations, there might be initiation of the combustion since they are acting like a artificial spark plug. But what we can do, the furthest charge may take part in the combustion, but we should not allow the formation of the propagation of the secondary flame, and for that if we take some preventive steps like whatever we have discussed, then perhaps we can reduce the detonation. So, from this today's discussion, from the today's discussion, what we can conclude that somehow we need to know what are the factors that affects the main flame speed. So, if we can somehow increase the speed of the main flame, probably we can reduce the chances of having detonation in the context of operation of spark ignition engine. So, what are the factors increases the main flame front, again I will discuss in detail, and that part I will discuss in the next class. So, with this I stop here today, and I will continue my discussion in the next class. Thank you.